In this video, we're looking at example 5, part A, in our section 5.5 on using integral tables to complete integrals. Okay, so before approaching this example, I just want to talk about the integral table chart a little bit more. So there are four main forms of integrals that we see on that page. And they look like the following. So integrals of the form involving a squared minus u squared, a squared plus u squared minus a squared, and a plus bu. So one note about these expressions here is that u is always the variable. We're always looking at a du, and a and b are constants, so fixed numbers. And so we can see that outlined in the integral tables where the headings involve those four different forms. All right, so looking at the integral that we have in part A, which of these four forms might most closely represent our integral? Well, if we think about it for a moment, we have a subtraction and we have some squared terms. So, and it looks like our variable is our first term and our constant is that value being subtracted. So if we think about it a moment, looks like it'd be this form we'd want to fit. Okay, so how might we do that? So how might we change this into an integral of the form square root of something variable squared minus some constant squared? So we can see then, if we want something squared to be 4x squared, we think about it, then that means what we'd want here would be 2x squared. And what squared would give us 5? Well, the square root of 5 gives us 5. So our integral is equal to the square root, or integral of square root, 2x, all of that squared, minus the square root of 5, all of that squared. So how would we make it into a form where our first term is just a variable and our second term is just a constant? Well, we see here that if we let u equal that 2x, then the du becomes 2 dx, which would mean du over 2 is equal to dx. And our original integral is a dx. Then we can get our integral into a more simplified form that has this u squared minus a squared involved in it. All right, so substituting in for u, this integral becomes the integral of the square root of u squared minus square root of 5 squared du over 2. And now I might as well bring that 1/2 outside of the integral just to simplify things a little bit. Okay, so now let's go over to our integral tables and consult and see if we can find an integral that looks kind of like ours. And again, we have the form u squared minus a constant squared. So let's look for that. Here we go, u squared minus a constant squared. And we see that that first integral we come across has exactly the form of our integral. Now for us, our a is the square root of 5. So that means our integral is equal to this lovely expression here. So we need to copy this down on our solution page. So it's helpful if you have this integral table printed out so that you can work on your notes and see the integral at the same time. I'll go ahead and copy it out for us, but I really encourage you to have your integral table out so you can check my work. All right, and so I always want to cite, we're going to use, it was formula 39, and we're going to have a equals square root of 5. So I have the integral table out on my other screen, and I have it printed out here. And so we're going to write out, we have this integral is equal to u over 2, square root of u squared minus square root of 5 squared minus square root of 5 squared over 2 times the ln of the absolute value of u plus square root of u squared minus square root of 5 squared close up that square root and absolute value, and then plus c. So we can clean this up a little bit. So to do that, we need to clean it up, which to do that, I'll finish what I was saying. We can square those square roots of 5s. That'll simplify things a little bit. We can just write 5 instead of a square root and a square. And we need to substitute back in for u. So let's go ahead and do that in the next step. So this is equal to 1/2 over, call u is equal to 2x. So we have 2x over 2, which the 2's cancel, so I can just write x, times the square root of 2x squared. So that again becomes my 4x minus 5 minus 5 over 2 ln of 2x plus square root of 4x squared minus 5, and that absolute value in the parenthesis, add a plus c. And there we have it. So our integral becomes this solution. Nice work. So without that formula table, we might have to use another method like integration by parts. And I don't know about you, but just looking at this final expression, that integration by parts might have been pretty tricky. All right, great work working through part A of this example 5.